Assalamualaikum warahmatullahi wabarakatuh. Today we'll discuss actually the solution for the tutorial sheet number 7, and the first question is answer the following questions based on the continuous time Fourier transform. So we are actually solving the questions based on the continuous time Fourier transform. So the first of all, it is to prove with all the steps the Fourier transform of the signal e power minus alpha t into u of t is 1 over alpha plus j2 pi f. So first of all, I will be solving the part A. So let me solve it. So we want to prove, so this is the first question, the part A, to prove that e power minus alpha t into u of t has the Fourier transform 1 over alpha plus j2 pi f. Okay, so we know that the Fourier transform of x of t is x of f, and the formula is integral from minus infinity to infinity x of t into e power minus j 2 pi f into t dt. But now x of t is a function with u of t, so the integration will be from 0 to infinity e power minus alpha t into e power minus j 2 pi f into t dt. And you know that we can combine these two. This is equal to e power minus alpha plus j 2 pi f is common, and into t is common in both. So integral 0 to infinity dt, and you know that this integral is nothing but 1 over, not 1 over, sorry, it is e power minus alpha plus j 2 pi f into t divided by minus of alpha plus j2 pi f. Okay, and the limit is from 0 to infinity. Now you see here, if I put the limit, what will happen? If I put infinity, it will become e power minus infinity, that is nothing but 0. So 0 divided by minus of alpha plus j2 pi f. Okay, then minus, okay, then e power 0 is 1, so 1 over minus of alpha plus j2 pi f. Okay, then you see here there are two minus sign here and this one, and finally it will become 1 over alpha plus j2 pi f. So minus and minus will cancel. So this e power minus alpha t into u of t has the Fourier transform 1 over alpha plus j2 pi f. So we have seen how to solve part A. Now what we will see is, you have to use part A and obtain the Fourier transform of z of t is equal to e power alpha t into u of minus t. That means what is the Fourier transform? That means we want to find the Fourier transform of e power alpha t into u of minus t using part A result. Okay, so this is what we want to do it. Now how to do it? We want to find the Fourier transform of this, but you know that there is a rule: if x of t has a Fourier transform x of f, then x of minus t has the Fourier transform x of minus f. So you know that e power as per result in the part A, this is the part A result, just put you can put t, replace t with minus t in part A. What happens here? Then it will become e power minus alpha into minus t, right? That means it is e power minus alpha into minus t into u of minus t. Okay, this will be having the Fourier transform. I have to replace f with minus f, so it will become alpha. Okay, it will become alpha. F I replace with minus f, alpha plus j2 pi minus f. Okay, so what will happen? You see here, it will become minus of minus, it will become plus e power alpha t into u of minus t has the Fourier transform 1 over, you see there is a minus here, so it will become alpha minus j2 pi f. So this is the result. Okay, so next what we will see is how to solve the Fourier transform of 5 into e power c. Okay, what is the Fourier transform of 5 times e power minus 3t into u of t? So what will happen? You know that this one is having the Fourier transform. We know that the Fourier transform of the first part, let me show you. The Fourier transform of the first part is nothing but it is in the form of e power minus alpha t into u of t. So it will be having the Fourier transform. What it is? Alpha. What is alpha here in this problem? You know that alpha is equal to 3. It is not minus 3 because the form that we have derived is e power minus alpha t. This is the previous derivation that we have done. So alpha is equal to 3. So it will become 3 minus j2 pi f. Now you see there is a multiplication with the 5. So we have to multiply with the 5. So what is the Fourier transform of 5 into e power minus 3t into u of t? This has the Fourier transform 5 over 3 minus j2 pi f. So that is the result. Okay. So that is the result. Next is we will see what is the Fourier transform of the part D of the question. You see, you know that it is given u of t has the Fourier transform half of delta of f minus j over pi f. Okay, and delta t has the Fourier transform which is 1. Then we want to find what is the Fourier transform of the signal y of t, and y of t is given as 4 times u of t minus 3 times delta of t minus 1. Okay, so we want to find the Fourier transform of this. So we will come to that question. I have just written the question here. So we want to find what is the Fourier transform of this y of t. Okay, this is we want to find it. And you see here there are two parts in this. This is 4 times u of t, and you know that 4 times u of t has the Fourier transform. U of t has the Fourier transform already we have. So you have to multiply with the 4. So 4 times half of delta of f minus j over pi f. Okay, this is the linearity property of the Fourier transform. Next, the next one is what? This is like minus 3. Okay, or minus 3 you can consider it, or doesn't matter. Anyway, you can consider minus 3 itself, the complete part you can consider. So it is nothing but minus 3 into delta of t minus 1. This has the Fourier transform. You see there is a multiplication factor with the minus 3. So minus 3 will be repeating here in the Fourier transform also. And delta of t is having the Fourier transform 1. So there is a rule for that. Actually, if x of t has the Fourier transform x of x, then x of t minus tau has the Fourier transform e power minus j 2 pi f into tau into x of f. This is the property actually. So we have to use this property here. So the property, it is, you see the delay is actually minus 1 here. So it will become delay is actually minus 1. So, or we can say the delay is 1, and this is in x of t minus tau. So what is t? What is tau? Tau is equal to 1. So it will become 3 minus 3 is already, we have to multiply it, e power minus j 2 pi f into tau. Okay, so what is tau? Here tau is 1. Okay, into the Fourier transform of the signal delta of t. What is the Fourier transform of delta of t? Already we have the answer. It is already 1. So we got the two parts actually. Now we will combine. You see, this is the part A and this is the part B. So we will combine to obtain the Fourier transform of y of t. So y of t has the Fourier transform. I can say I have A, then also B. So I have to add A and B, because already by adding, because already I have considered the minus sign. So this will become, you see here, this signal, you see this is 4 times 1 over 2. It will become 2, right, times delta of f minus j over pi f. Then there is here minus 3 times e power minus j 2 pi f. Okay, so this is the Fourier transform of this y of t. So we can say that this is our y of f. Okay, so we got the answer. So part D we have solved it now. So that's it. So this is what the question number 1. Okay, now we will see what is the match the following actually situations. You can see here I will just take some pencil. Okay, so you can see here the match the following. This is question number 2. Okay, the first one is the Fourier series of the impulse train. Yeah, the Fourier series of the impulse train is what? 1 over t naught. So the answer for 1 is actually A. The answer for 2, so this is having the answer A. Okay, the Fourier series is actually the Fourier series is applicable to the periodic signal. So the Fourier series is applicable to the periodic signal. That means option D. Okay, the Fourier transform of the rectangular pulse, it is a sinc function. So the Fourier transform of the rectangular pulse is a sinc function, which is B. Okay, the Fourier transform of e power j 2 pi f naught into t. If I multiply with e power j 2 pi, I will be having a shifting to right side. That means the frequency will be shifted to right side. So this is the option. So 4 has the option C. So I have shown you everything here. I have written here in the answer key. Okay, so the next is we have the third one. Okay, the third question. Answer the following based on the continuous time Fourier transform. Again, everything is based on the continuous time Fourier transform. So first of all, we have to prove that the Fourier transform of the signal, a rectangular pulse, is a sinc function. That means a tau into sinc tau f. So I will show you the proof. Actually, I have already derived in the class. So the first part is to prove that the rectangular pulse a rect of t over tau has the Fourier transform a tau into sinc tau f. So what this is our signal now x of t. Okay, so you see the signal is looking like this. The width of the rectangular pulse is given as tau. So this is tau over 2 and minus tau over 2, and the amplitude is a. This is our rectangular pulse. Okay, now we will find what is the Fourier transform of this. So we will take the formula, the same formula, integral x of t into e power minus j 2 pi ft dt from minus infinity to infinity. So in this case, the signal is starting from minus tau by 2 to tau by 2, and a times e power minus j 2 pi f into t dt. So again, you know, this is a into e power minus j 2 pi f into t divided by minus j 2 pi f, and the integration limit you have to put minus tau by 2 to tau by 2. Okay, so this will become a, okay, over minus j 2 pi f into e power minus j 2 pi f into tau by 2 minus e power minus j 2 pi f into minus tau by 2. So this is what the function. Now you see this will become a over minus j 2 pi f, and I will write, you see, this is the first part and this is the second part. I will write the first two, then I will write 1, and I will take the minus. You see this minus sign, I will take outside. So minus is outside. So I will write, then I can write the first part as a positive. So it will become minus, and you see here there is a minus here and there is a minus here. It will become plus. So plus j 2 pi f into tau over 2. Then the second part, the part 1 will become minus. Now this will become e power minus j 2 pi f into tau over 2. Now you see, I can cancel out these minus signs. There is a minus sign here, there is a minus sign here. What I will do, I will cancel it. Okay, so this will become a over, okay, I can write it as, and also I can move this 2j here. I can move it. So this will become a over pi f divided by 2j, then e power j 2 pi. Okay, I can cancel something else also. I can cancel this 2 and this 2 and this 2 and this 2. I can cancel it, right? So I will be getting e power pi f tau minus e power minus j pi f tau. Okay, then this is what a function which is called a sine function. This is a sine function, right? So this will become a over pi f sine, okay, pi f tau. Now you see, I will move this pi here, so the pi will be here now, so I can remove from this portion. Then you see f also I can move it, so I will remove f from here and I will put it here. Okay, now you see this is a function which is called a into sine pi f tau divided by pi f. Now I want to convert it into the sinc form. What I will do, I will multiply here with tau, okay, and here also I will multiply with tau. Then the tau will cancel, right? So this will become a tau. Now you see this part is actually sinc function. So sinc, when I write it as a sinc, I can remove the pi. So f tau, okay, or f tau or tau f. Okay, so usually we'll be writing it as tau f. So sinc tau f. So this is what the proof for the first part of the question number 3. Okay, next we will see what happened. What is the second part of this question? And okay, you see here the second part of the question. I think, yeah, it is somewhat similar to the first part, the first question. So I will write it down. Okay, then I will show you. So u of t has the Fourier transform half of delta of f minus j over pi f, and also given delta of t has the Fourier transform 1. Okay, then you want to find what is the Fourier transform of the signal y of t, and y of t is given as 3 times u of t plus 3 times delta of t minus 6. So it is similar to the question number 1, the last part of the question number 1. Okay, so now you see what we can do. You see, I have 3 times u of t. So 3 times u of t has the Fourier transform 3 into 1 over 2 into delta of f minus j over pi f, because u of t is having the Fourier transform, it is already given. Then what is there? It is plus. Okay, then what is the Fourier transform of this one? What is the Fourier transform of this? It is 3 times, and delta of t is having the Fourier transform 1, but it is shifted by tau units. As I have told you in the question number 1, if something is shifted, this is the property. X of t minus tau has the Fourier transform. You see here, x of t minus tau has the Fourier transform e power minus j 2 pi f into tau. So we can write in the same way. It is like e power minus j 2 pi f into, here you see the tau is equal to 6. Okay, so into 6 into the Fourier transform of delta of t, it is what? It is 1. So the Fourier transform result is the y of t has the Fourier transform y of f. The Fourier transform is y of f, which is equal to 3 over 2 into delta of f minus j over pi f plus 3 times e power minus j 2 pi f into 6. So 6 into 2 become 12. So this will become 12 pi, right? So minus j 12 pi f. Okay, so that is the Fourier transform. So if you find any mistake in my solving, actually you can please report to me, right? I will do the correction. So that's it. So we have seen the question number 3 also. Next is the question number 4. In the question number 4, you see here, I will make it a little bit smaller, right? Yes. Now you see the question number 4 is a match the following question. And first of all, the Fourier series of a given signal, it is what? The Fourier series of an not given signal, sorry, even signal. It will contain only cosine terms, right? So the Fourier series of a signal, the first part, actually the first one, actually the answer is what? It will contain only the cosine terms, right? So it will contain only cosine term. That means the option D. Okay. So the first part is option D. Then the second part, actually, the Fourier series of the periodic rectangular function, you see it is a discrete sinc function. Okay, it is a discrete sinc function. So the 2 is having the option A. Okay. Next is the Fourier transform of the signal which is real and even. Okay. So the Fourier transform of a signal which is real and even. If the signal is real and even, the Fourier transform also will be real and even. So option 3 is having the answer, right answer as B. Okay. Then the Fourier transform of e power minus j2 pi f naught into t. You see that this property is like if you are multiplying with e power minus j2 pi f naught, it is a frequency shifting property. Then the spectrum will be shifting left, right? That means the option 4, the 4 is having the option C. So this is what the answer. Okay, I have written it in the sheet. Okay, in the key. So the next one we'll see. Okay, the next one. So it is given that the question number 5, actually it is given, I will write down it and I will show you. So given actually u of t has the Fourier transform half of delta of f minus j over pi f. Okay. And also it is given e power minus alpha t into u of t has the Fourier transform 1 over alpha plus j2 pi f. Okay. And also delta of t has the Fourier transform which is 1. All the Fourier transforms are given. You want to find what is the Fourier transform of x of t is equal to 1. Actually, you want to find what is the Fourier transform of the signal x of t is equal to 1. So I will first solve this, then I will show you what are the other solutions. So it is given that u of t is given. You see here d of t is given, the Fourier transform is given. So Fourier transform is given, and e power minus alpha t is also having the Fourier transform, something like e power minus 1 over alpha plus j2 pi f, and delta of t is having the Fourier transform 1. We want to find x of t is equal to 1. So if you compare this, you can see that delta of t is having the Fourier transform 1. So we will take down this. Delta of t is having the Fourier transform 1. And you know that the duality property, it is very important property. So by using duality property, if x of t is having the Fourier transform x of f, then I told you if you replace this x in the time domain, actually if it is coming x as a function in the capital X as the function in the time domain, then you can replace actually what you can do, you can replace this in the Fourier transform will be x of this t can be replaced with the minus f, or you can do in this way, x of minus t is having the Fourier transform x of f. Okay. So both are actually, this is called the duality property of the Fourier transform. So we can apply this. So now you see delta of t has the Fourier transform 1. It is given in the question. So if I replace this 1 here, then I can replace this delta with, I can replace the t with the minus f. But what is delta of minus f? It is same as delta f. So my answer is 1 has the Fourier transform delta of f. Okay, actually it is delta of minus f, but delta of minus f is same as delta of f. So this is what the first part. Okay, the second part is, so the first part is to apply the duality property. Next, the second part is the Fourier transform of the signal y of t, and y of t is given 2 times u of t plus delta of t minus 4. It is something like the previous problem. So it's very easy. You know u of t is having the Fourier transform. What? So you have to multiply with 2 times. The u of t is having the Fourier transform half of delta of f minus j over pi f. That we have already seen it. Okay, this part. Then, but you have to multiply with the 2. Then you see there is a plus sign, plus what? Delta of t minus 4. Whenever it is said there is a delay, then the Fourier transform of delta t is already, it is given delta of t is having the Fourier transform 1. So it will become e power minus j 2 pi f into 4, f into tau, into the Fourier transform of delta of t. The Fourier transform of delta of t, you know that it is 1. So I have to write it as 1. So what is the Fourier transform of y of t? I can say it is y of f. It is equal to, this 2 and 2 will cancel. You see here, 2 and 2 will cancel. So it will be delta of f minus j over pi f, then plus, what is this? It is e power 4 into 2 become 8. So e power minus j 8 pi f. Okay, so this is the Fourier transform of y of f. Okay, of y of t. So we got the Fourier transform of y of t. Next, we want to find what is the Fourier transform of e power alpha t into u of t. That we have already seen it. Anyway, I will show you. So these questions I have previously asked for the exams. So e power minus alpha t into u of t has the Fourier transform 1 over alpha plus j 2 pi f. That we have already seen it. Now we want to find what is the Fourier transform of the signal e power alpha t into u of minus t. So this is what the question. So I will show you now. So this is what we want to find it. So you see here, replace t with minus t. This is what happening actually. So that is my, so if x of t has the Fourier transform x of f, then x of minus t will be having the Fourier transform x of minus f. So if you replace t with minus t, then you have to replace f with minus f. So what is that? Now you see, I will take this Fourier transform. I will replace e power minus alpha into minus t into u of minus t. Then this has the Fourier transform 1 over alpha plus j 2 pi f. I will replace with the minus f. So what this will become? E power alpha t into u of minus t. This is what exactly our question. Okay, so this you should identify. Then it will become 1 over alpha. This is minus f. So plus will become minus j 2 pi f. So this is the answer for the part C. Now let us see now. Yes, we want to find what is the Fourier transform of 1 over alpha plus j 2 pi t. Yes, so we want to find the Fourier transform of 1 over alpha plus j 2 pi t. What is the Fourier transform of this? So I will just show you now the solution. We want to find the Fourier transform of this. Actually, we know e power minus alpha t into u of t has the Fourier transform 1 over alpha plus j 2 pi f, right? So I can actually take I can actually use the duality property. Actually, I have shown you the duality property. If I use this duality property, replace just t with f in that function, then what will happen? So you see here, this function, I am going to take it here, 1 over alpha plus j 2 pi. Instead of f, what I will put here? T. So if I put here t, then the Fourier transform will be e power minus, this one I have to take it, e power minus alpha into, you see here, this is t, I have to replace t with the minus f, right? I have to replace t with minus f into u of, you see here I have again t, u of t I have to replace with minus f. So it is very clear now, 1 over alpha plus j2 pi f, not f, t, this has the Fourier transform e power alpha f, a minus of minus will become plus into u of minus f. So this is the answer. So this is by using which property? Duality property. So study the properties very well. So we got complete solution for the question number 5. Next is the problems with the discrete Fourier series. Okay, discrete Fourier series. Discrete time Fourier transform. I am sorry for this, discrete time Fourier transform. So we are now going to do the problems related to the discrete time Fourier transform. Okay, previously we have done the problems related to the Fourier transforms. Okay, so mainly these were related to the Fourier transform. Now Fourier transform means this is actually the first one was with the continuous case. Okay, continuous case, and we have seen the other one, it is the discrete time Fourier transform. So what is the first question? We will see now. See, the question is, the signal is given x of n which is equal to 0.8 whole power n into u of n. Okay, and u of n is a unit step sequence. You want to find what is the DTFT, that means discrete time Fourier transform. Okay, so I will show you the answers now. Okay, so if you want to find the discrete time Fourier transform of a signal e power j omega x of n has the Fourier discrete time Fourier transform DTFT, which is x of e power j omega. What is the formula? It is from a summation for all n. Okay, you have to consider all n, x of n into e power minus j omega n. This is the formula. So this is a signal which is starting from n equal to 0 and going to infinity. So this will become summation n is equal to 0 to infinity 0.8 whole power n into u of n, because you don't need to write again u of n because it is a signal which is going from 0 to infinity. Now this is e power minus j omega n. Okay, so this is our signal, and we want to find the Fourier transform of we are going to find the Fourier transform of this. See, now this will become what? Actually, if n equal to 0, then it will become 1, right? Then plus, then 0.8 times e power minus j omega plus then 0.8 the square times e power minus j 2 times omega, then 0.8 cube e power minus j omega into 3, and so on. So this is equal to 1 plus 0.8 into e power minus j omega whole power 1, is it okay, plus 0.8 again e power minus j omega whole power 2, right, plus 0.8 into e power minus j omega whole power 3, and so on. So let us consider r is equal to 0.8 into e power minus j omega. Okay, then this is in the form of, let r like this. So this is in the form of 1 plus r square plus r cube plus this one, and this summation is 1 over 1 minus r, provided the magnitude of r is less than 1. But of course in this case we can see that the magnitude of 0.8 into e power minus j omega is equal to 0.8 and it is less than 1. So we can do by using this summation. So this is 1 over 1 minus 0.8 into e power minus j omega. So this is my uh, Fourier transform, which is e power of e power j omega. Okay, so this is how to find it. So I think this is what. The next problem, I will just solve the next problem. You see, I will write down the next problem. X of n is a sequence which is 1, 1, minus 1, and minus 1. And with the x of 0, is the first value. X of 0 is the first value. Okay. Find the DTFT. We have to find the DTFT of the signal. So DTFT of the signal. So we have to find the DTFT of this signal. So how we will do it? We can easily find it. I will show you the answer. So we are having the signal. So we'll use the same formula as we have used before. So this will become x of 0. So x of e power j omega is nothing but x of 0 will be multiplied with the, okay, I will show you the formula first. This is equal to summation for all n x of n into e power minus j omega n. So this will become x of 0 first, x of 0 into e power minus j omega 0. Okay, then x of 1 into e power minus j omega 1, x of 2 into e power minus j omega 2 plus x of 3 into e power minus j omega 3. But this is the point with n equal to 0. It is already given in the question. So what we can do now? So this is the first two values are 1, then the other two values are minus 1. So 1 into e power j omega 0 is again 1, plus again it is 1, the next value is also 1 into e power minus j omega, plus next value you see here it is minus 1, so minus 1 into e power minus j omega into 2, plus minus 1, again minus 1 you have seen, into e power minus j omega into 3. So this will become 1 plus e power minus j omega minus e power minus j2 omega minus e power minus j3 omega. So this is the Fourier transform. We can reduce it also somehow in terms of cosine and sine, because e power j theta, you know, e power j theta is equal to cosine theta plus j sine theta, and that form also you can write it in terms of sine and cosine. That is also possible. Okay, question number 7 is finished. Next is the question number 8. Okay, question number 8. So we'll see the question number 8 first. I will just write down the questions. X of n is given as 0.5 the whole power n into u of n plus delta of n minus 3. Okay, so what we have seen already, we want to find what? We want to find the DTFT. So there is a first part actually in the question to find the DTFT of the signal. Then we want to find the region of convergence. Region of convergence means actually in which region actually we can find the DTFT of this signal. And we have seen this in the previous problem, this kind of example. Actually this one is something like a power n into u of n, but in this case what is a is equal to 0.5, and we have seen in the previous problem like a power n into u of n case, like 0.8 case, actually what was the Fourier transform? It was something like this, right? Okay, this one was the Fourier transform. So it will be, instead of 0.8 now we have 0.5. So the Fourier transform I will solve with the step anyway. It will become, let me just go through it. 1 second. Yeah. So x of e power j omega is equal to summation for all n x of n into e power minus j omega n. So we can calculate it easily. It will be, you see the signal is only in this duration. The first part of the signal, I can say there is first part for the signal and there is a second part for the signal, right? Second part for the signal. And what is this signal? This signal is 1 at n equal to 3. So at n equal to 3, then only it is 1, because it is a delta function which is shifted by 3 units. Okay, so easy to find the Fourier transform. So I will first find the Fourier transform of the first part. Okay, so I can say part 1 and part 2. Okay, so it is easy to find the Fourier transform of this. Sorry, yeah. Now you see the Fourier transform of this signal is like 0.5, right? It is 0.5. So 0.5 into e power minus j, 0.5 times 0. So in our case, it is a signal with a u of n. So it will start with 0, 0.5 power 0 into e power j omega 0 plus 0.5 times 1 into e power minus j omega times 1, then 0.5 times 2 e power minus j omega times 2, and so on. Okay, this is the first part of this. Okay, I am talking about the part 1. Actually, the part 1, this is the situation. And for the part 2, you know that the signal is existing only at n equal to 3. So for the part 2, I can say that so this can be, I will write it as part 1 plus part 2. So the part 1 is like this plus the part 2. What is the part 2? The part 2 is a delta function, so it is very easy. So it will become, the Fourier transform will be equal to 1 times e power minus j omega into 3, because it is happening only at n equal to 3. So this is the Fourier transform. So for the part 2, now our answer, you see, for our signal x of n, I can say x the Fourier transform, our x of n has the Fourier transform x of e power j omega, which is nothing but, what is it? It is nothing but the first part plus second part. But first part, you see, I have already given this is equal to 1 plus 0.5 into e power j minus j omega whole power 1 plus 0.5 times e power minus j omega whole power 2, and so on, plus the last one, actually e power minus j omega into 3. So this will become, this is in the form of 1 plus some r plus r square plus r cube plus and so on, plus e power minus j omega into 3. But this is having 1 over 1 minus r plus the last one is e power minus j omega into 3. So this is equal to 1 over 1 minus r is what? 0.5 times e power minus j omega, right? So this is what the same kind of thing that we have already written. So the same kind of stuff actually. So you see here, this plus e power minus j omega into 3. We have, I think, how many questions are there? Yeah, 2 more questions left. Actually, we want to find the DTFT of this sequence. Okay, this will take a little bit time anyway. DTFT of the sequences, we want to find it, and I have given you, okay, this is the 9th question. It is given x of n is equal to 1, 0, minus 1 and 2. So this is the sequence. Okay, you want to find the 4-point DFT, 4-point DFT, and you have to, the second part of the question, write the answer in the form of okay, you have to write the answer in the form of x of k is equal to a plus jb form. Okay, you have to write for each k, so it is not a big deal. So we will see now. I will show you one thing in our, just give me some time. What is signals and systems? Lecture notes, the last lecture note. Okay, the last lecture note, everything is mentioned clearly. Please study the Fourier transform, discrete Fourier transform, and this is the matrix actually, that DFT matrix. So you can make use of this DFT matrix, and I have already derived this in the class, and you can see that this is my matrix with a 4-point DFT case. Okay, so for a 4-point case, actually I will write it down. I will write the DFT matrix. You see W4 bar, it is nothing but 1 1 1 1, then 1 minus j minus 1 and j, 1 minus 1 1 and minus 1, 1 j minus 1 and minus j. The computation of this I have already discussed in the class. Similarly, IDFT matrix also I will write it down, which is W4 inverse, which is nothing but I will show you W4 inverse. I will show you it is nothing but 1 over 4 times the Hermitian transpose of this. Okay, I can write like this. So this is nothing but 1 over 4 times W4 bar Hermitian. So it is 1 over 4 times, I will take the Hermitian transpose of the previous one. What it is, you see the rows will be written as columns, and the complex number will be written as a complex conjugate. So 1 1 1 1, then I will write 1 minus j will become plus j, but minus 1 there is no change, and j become minus j. Okay, then again this will be 1 minus 1 1 minus 1, then the last one will be like 1, I am just writing it as a column, so it will become minus j. Anyway, a complex conjugate will be taken, minus 1 and j. So this is what the inverse of that, or we can say 1 over 4 times W for Hermitian. Okay, so by using this idea, I will show you how to solve this. Okay, now I have first defined the DFT matrix, and in this problem I need to calculate only the DFT and write the answer in the form of this. Already you will be getting the answer in the same form anyway. So what we will do is I will first write my x, the signal x, as a I will write my signal x as a matrix. So it is, the signal is what, 1 0 minus 1 2. So x is 1 0 minus 1 and 2. Let me check it again. Yeah, so I think that is a signal 1 0 minus 1 2. Okay, so what we will do, I want to find the Fourier transform. So x bar is equal to Wn bar into x. Okay, so this is nothing but, you see, I have write the same matrix. So let me copy and paste from here. Copy. Okay. Okay, now this is my W into X. So 1, 0, 1, 2. Sorry, minus 1, 2. So now you can calculate what is X, which is equal to, you know, the matrix multiplication 1 into 1, then this 1 into 0, and then this 1 into minus 1. So it will become 1 into 1 is 1 plus 0 plus 1 into minus 1 is minus 1 plus this is again 1 into 2, it will become 2. Okay, if there is any mistake, please try to rectify it. Then the second one, then the second row, it will be 1 into 1 is 1, then minus j into 0 is 0 plus minus 1 into minus 1 is 1 plus j into 2 is 2j. Okay, then the next one, the third one, the last one, not last one, third one, it is 1 into 1 is 1, then 1 minus 1 into 0 is 0, 1 into minus 1 is minus 1, then minus 1 into 2 is minus 2. Okay, then 1 into 1 is 1, j into 0 is 0, minus 1 into minus 1 is plus 1, then minus j into 2 is minus 2j. So my x, I will get it as 1 minus 1, the first one, 1 minus 1 plus 2, it is 2, then 1 plus 1 is 2, 2 plus 2j, then 1 plus 0, minus 1, so 1 plus 1 minus 1, then minus 2 is the answer, then 1 plus 1 is 2, then 2 minus 2j. So I hope this is the signal. Let me see again. So it is 1 into 1 minus j into 0, then minus 1 into minus 1 and 2j. I hope this is okay. So my x is equal to, actually it is x of 0, x of 1, x of 2 and x of 3. My answer is what? 2, that means 2, then 2 plus 2j, then minus 2, then 2 minus 2j. So it is just a matrix multiplication. We got all the values, x of 0, x of 1, everything. Okay, and as mentioned in the question, the answers are also in the same form as mentioned in the question, like right answers in the form of a plus gb. So all these answers are in the form of a plus jb. All the answers are in the form of a plus jb. All answers are in the form of a plus jb. Okay, so that is what this problem. Okay, the next problem is, so the problem number 9 is finished. The next problem is the problem number 10. Okay, and it is given x of n. Okay, it is equal to 1 1 1 1. This is my signal. Okay, so we want to find the 4-point DFT. This we want to find the 4-point DFT. Then we have to comment on the, we want to find the magnitude of x of k. Then the another part is comment on the frequency characteristics. Then the fourth one, it is to find by using the DFT matrix. Anyway, we'll be using DFT matrix. Okay, use DFT matrix and compute it. Okay, use DFT matrix. Then find IDFT of answer to obtain x of n. Okay, so it is little bit lengthy. Anyway, I have written all the questions, what are all there. So now you see, this is a this is the problem. Actually, we can here we can use matrix multiplication, but it is given in the question. We can use the matrix multiplication method here. So what I will do, I will just use the first part. Actually, I will use it by using the normal technique. What it is, solution x of n has the Fourier transform. That means the discrete Fourier transform, which is x of k. And how to find it? Summation for n changes from 0 to n minus 1, x of n into e power minus j 2 pi over n into k. So how to find it? This is equal to 1 times the first point in the signal is 1, and then n equal to 0, it will become e power minus j 0, okay, minus j 2 pi over n into 0 into k. Again 1, e power minus j 2 pi over n, and you know that what is n actually. I have to substitute the value of n. It is asked to find the 4-point DFT. So what is n? N equal to 4, right? So I will just put it as 4 here, 4 here, okay. Then 0, after 0 it is 1 into k plus 1 into e power minus j 2 pi over 4. Then it is, instead of 1, it is 2 into k, then plus, again the signal amplitude is 1 because all the amplitudes are 1, into e power minus j 2 pi over 4 into 2k. What is 2k? Not 2k, the next it is 3k, right? That's finished. Okay, that's finished. Now you see, this is the first part, this is 1, and you know that this is 0. So 1 plus e power, you see there is a 2 here, then there is a 4 here. So this will become e power minus j pi over 2 into k plus e power minus j pi over 2 into 2k, but 2 again will cancel. So I will be getting e power minus j pi k, isn't it? Plus e power minus j, it will become pi over 2 into 3k. Okay, so now I can do this calculation by expanding 1 plus, this is nothing but cosine pi over 2k plus j sine pi over 2 k, right? This is the first one. Then the next one is cosine pi k minus j, again it should be minus here, sorry, so it should be minus j sine pi k. So that's it. Then the last one, which is nothing but cosine of pi over 2 into 3k, right, plus sine, not plus, it should be minus j sine pi over 2 into 3k, right? That's it. Now we have to calculate, this is the equation for x of k. Now you can find x of 0, x of 1, x of 2 by putting the value of k, and you can do the calculation. So you can put you can find x of 0, x of 1, x of 2, then x of 3 by using the calculation. Okay, so in the equation this will become 1 plus cosine of pi by, if you put k equal to 0, what will happen here? If you put k equal to 0, cosine of 0 will become 1, right? Then sine of 0 will be 0, cosine of again 0, it will be 1, so plus 1. Okay, this is what I am going to get it. It is 4. Next is 1 plus cosine. Then if I put k equal to 1, it will become cosine of pi by 2. Cosine of pi by 2, you know that the first part actually I'm saying, cosine of pi by 2 will be equal to, this is 1 plus cosine of pi by 2 is equal to 0 minus j times sine of pi by 2 is 1 plus cosine of pi. Cosine of pi is minus 1, right? Minus 1 minus j sine of pi. You know that this one, j sine of pi is, cosine of pi is minus 1 and j sine of pi is 0. So minus 0, then plus cosine of pi by 2 into 3. So cosine of pi by 2 into 3, it is what? Cosine of cosine of pi by 2 into 3. That means 3 pi by 2. Cosine of 3 pi by 2. What is the value? This is the cosine function. So pi by 2 here, then this is for 2 pi by 2 and 3 pi by 2. It is 0, I think. Yeah, it is 0. 4 pi by 2, it is again 2 pi. So it will become, so it is 0, then minus j times sine of 3 pi by 2. Sine function is something like this. So this is here pi by 2, then what it is, 2 pi, then this is minus 1 actually. So sine of that is minus 1. So minus j into minus 1, it will become plus j. Okay. So this is how to calculate. Okay, I'm not showing the complete calculation, that is not needed anyway for this problem. So you have to calculate like this actually. Next part is we will see next what we want to determine the magnitude of x of k. Okay, the magnitude of x of k, you can find it by using the first equation itself. So this is the first part actually. I can find the magnitude of x of k be the magnitude of x of k by separating out the real and the imaginary part. So x of k is equal to 1 plus cosine of pi over 2 into k. I will take the real part of only the real part, plus cosine of pi over 2 into 3k, then minus j times what it is, sine of pi by 2 into k plus sine of pi k plus sine of pi by 2 into 3k. That's it. Okay, so I have the two parts. One is what, let's say a, and the second one is what, b. So the magnitude of x of k is nothing but the root of a square plus b square. Okay, that you can calculate it. This is what the magnitude of x of k. So this is how do you have to write. So this will become the root of 1 plus cosine pi by 2 into k plus cosine pi k plus cosine pi by 2 into 3k, the whole square, plus, okay, what, I can write it, plus sine of pi by 2 plus sine of pi k plus sine of pi by 2 into 3k, the whole square. Okay, this is what. Okay, so simply this is what you can do. Otherwise you have to substitute the value of this. So this is the magnitude spectrum of x of k. So this is magnitude of x of k. Okay, so next is the C, the part C. So what I have done is, sorry, it was not visible to you. What I have done is, I have separated out the real part. So this is the real part, this is a real part, and this is a real part, and I have separated out the real part. So all this will become the real part. Then I have separated out the imaginary part. So all this actually become the imaginary part. So the real part is a and the imaginary part is b. So the magnitude is root of a square plus b square. So I have just calculated. So this is nothing but a square and this is nothing but the b square. Okay, so this is what the spectrum. Next is magnitude spectrum of x of k. Next is we want to find get it by using the DFT matrix. So I will again use the DFT matrix for the computation. So here I have, right, this my formula. So I will take this formula, sorry, I will take the complete formula from here. Only the signal is different. Up to this is fine. So I will take it from my previous question. So this is my W, and I will show you clearly what is this 1, 1, 1, and 1. This is my DFT matrix. Okay, WN, and my signal is now, it is 1, 1, 1, 1. Okay, so this is nothing but x, which is equal to x of 0. Okay, just x. Okay, I will write it as x now. X bar, which is 1 plus 1 plus 1 plus 1, because just multiplied this with 1, then multiply this with this, then plus this plus this into this, like this. Okay, next is what? 1 minus j minus 1 plus j. Next is 1 minus 1 plus 1 minus 1. Then the last one is 1 So last one is 1 plus j minus 1 minus j. So this is equal to 4, then 1 minus j, then this is 0, then again 0, again 0. You see, this is the Fourier transform of this function. Okay, so if you calculate also here, you will get it as 0 in the previous. Okay, and similarly you will get here also as 0. Here also you will get it at 0. So what is our x of 0, x of 1, x of 2, x of 3? You will get the answer as 4, 0, 0, 0. It is like an impulse signal, right? With the amplitude 4, delta of n at n equal to 0. And this is up to n minus 1. N minus 1 is 3. This is 1, this is 2. So you see here, when this is when our question, you see, this is similar to a DC. It is similar to a DC. That means all the amplitude are same, a constant signal. So if it is a DC, you know that the Fourier transform in continuous case, it is what? 1. So we are getting something similar. Sorry, if it is a DC, the Fourier transform is a delta function at n equal to 0. At t equal to 0. The same thing is happening here also. You see the Fourier transform of a DC. So if I take a signal which is DC signal, something like this, similar to a DC, the Fourier transform, I am getting 4, 0, 0, 0, right, which is like a delta function. Okay, so this is actually a delta of n, which is okay, this is something like that. So this is what the observation. Okay, now what is the last part of this sheet is this: find the IDFT of this answer. So this is our x. So to find the IDFT, okay, you got the answer by multiplication. I can say the magnitude is to the frequency characteristics of the signal. Okay, this is D actually. What is the frequency characteristics of the signal? Okay, the frequency characteristics of the signal, that now we got it. The part C, actually I can answer here only the third part. Say this is the fourth part, and this is the second part anyway, and the other one is the first part of the question. This is the first part of the question. Okay, so the signal frequency characteristics, it is a delta function. It is a delta function. It is a delta function, right? Because it is having the value 4 0 0 0. That's why. Okay. So that is what the part 3. The last part, fourth one is already solved. The last part is IDFT. So I can show this is the third part. The third part is what? The signal frequency characteristics. It is similar. It is a delta function which is 4 0 0 0. So it is similar to a delta function. This is what I want to tell you. Nothing else. Now we want to find the IDFT. So we want to find the IDFT of this answer actually. So how we will find the IDFT of this answer? The last part is to find the IDFT. That means we are going to find what is x. So it is 1 over n into Wn Hermitian into capital X. This is the formula for IDFT. So 1 over 4. The Hermitian transpose of that, already we have solved it in the previous problem. Let me take it from our previous problem. Yeah, here it is there. So I don't want to write it again. So I will copy. This into our signal. Okay, this will give you what? X bar into our signal, which is 4 0 0 0. Okay, so this is 1 over 4 into this is 4. Then you will get here 1. You will get here 1 into 4 is 4. Again you will get it as 4, and again you will get it as 4, right? So the answer is 1 1 1 1. This is nothing but our signal X. So what is our signal X? It is X of 0, X of 1, X of 2 and X of 3. So same like our question. So if I take the IDFT, so this process is for the IDFT, but you have to understand the signal frequency characteristics is similar to a DC. You know that in a continuous case, the DC signal is having the Fourier transform what? Delta of f, which is at f equal to 0. And here also the signal is actually, it is a DC signal. You see that this is similar to a DC signal, and I am getting something like a delta function. Okay, like a delta function. So this is what's happening in discrete time also. So everything is very similar. So you'll be getting the same shape, but here it is a discrete. That's it. Okay, I hope everything is clear. Thank you. Study well. This tutorial sheet is very, very important. The important part that you have to study is what? Continuous time Fourier transform, then continuous time Fourier series, continuous time Fourier transform, then in discrete case, discrete time Fourier transform and discrete Fourier transform. Okay, then the last one is the sampling. So but please study the sampling from the theory note. Okay, from the lecture notes. Study the sampling from the lecture notes, and some problems I have already discussed in that. Okay, it's very important. So these are all very, very important. Okay, important for the final exam. So you may get one question from the continuous time Fourier transform or continuous time Fourier series, DTFT, DFT, and the sampling. Very, very important. Okay, thank you. Study well. I will share this in the Blackboard. Thank you.